In this video, we're going to go over section 5.2, which covers multiplication and division of integers. We're really just going to be going over some visual models for how you can introduce multiplication and division of integers to your students. So we have three models of integer multiplication that we're going to cover today. We have what we call the chip model, which is going to use your algebra tiles. Then we have the number line model and the pattern model. So the chip model for multiplication is going to use the same setup as the chip model for addition. And in this model, we are going to be thinking of multiplication as equal groups. We know that in the last unit we learned that there are lots of different ways to think of multiplication, like skip counting, rectangular arrays, area, or repeated addition. And with the chip model, we want to solely think of multiplication as repeated addition with equal groups. So let's multiply 34 times 7 using the chip model. Now, if you were doing negative 34 times 7, then you would want to make sure that you emphasize that, we use the red chips for negative numbers, yellow chips for positive numbers. But in this scenario, since we are just working with all positives, I just used a random color for my chips. So we're going to begin by modeling 34 on the place value chart. Alright, so hopefully you all agree that this represents 34 using our chips. We have 3 10s and 4 1s. Alright, so then we're going to model 7 groups of 34. We already have 1 represented here, so let's put 6 more. 2 groups of 34, 3 groups, 4 groups, 5 groups, 6 groups, and 7 groups. Alright, so if you want to take a second, pause the video and count these up, we could get our unsimplified product. Alright, so we're going to have to do some regrouping to get the simplified product, but let's count these up. We have, in the tens column, we have a rectangular array. It's 3 columns and 7 rows, so we know that's 21 tens. And then in the ones column, we have 4 columns and 7 rows, so that's 28 ones. Alright, so now we're going to look for an opportunity to do our exchange rate. And just to remind you of the exchange rate when you're working with these chip models or with base 10 blocks, 10 littles equals 1 big. Right, so that's kind of a general way of describing it that would apply to going from ones to tens, tens to hundreds, hundreds to thousands, whether you're using chips, base 10 blocks, etc. Alright, so we're going to look for opportunities to do our exchange rate of 10 littles equals 1 big. We see that there's lots of opportunities here. We have lots of chips represented here. It doesn't matter which exchanges you perform first. Alright, so if you want to start with the ones and group 10 of the ones, make them into 110, move them over, you can do that. I just randomly began by grouping the tens together. Alright, so you can see I've highlighted 10 of my chips here in my tens column. I'm going to combine those and make them into one 100 chip. I'm going to do the same with another 10 chips in the tens column. I'm going to combine those and make them into 1 chip or exchange those for one 100 chip. So those are gone now. You can see that we have left 2 chips in the 100s column, 1 chip in the tens column, and then 28 ones. Alright, so just making that look a little neater. Now we're going to start exchanging our ones. Alright, so remember our exchange rate, 10 ones equals 110. 10 littles equals 1 big. right, so there is 10 ones. We're going to exchange that for 110. Another 10 ones. Going to exchange that for 110. We have 8 remaining, so we don't have another 10 littles to group together. So I'm going to remove those ones, reorder, or just, make everything look a little neater. And now here's my simplified product. I have 2 100 chips, 3 10 chips, and 8 1 chips. So that's 238. 34 times 7 is 238. Now we're going to look at the number line model for multiplication. Recall the rules for walking the number line. Always start at 0 and always face the positive direction. If the number is positive, we're going to walk forward. If the number is negative, we're going to walk backward. Now, with multiplication, remember we're doing repeated addition here, so instead of walking forward, we're going to be hopping or jumping forward or jumping backward. All right, so we're going to start by multiplying 4 times 2 using our number line model. You can see that we have our cat on the number line. The cat is facing the positive direction. Y'all, was having so much fun doing this yesterday, so please excuse me. And then, so you can see that my cat has jumped one group of 4. It hopped 4 units. I need to hop 4 more units to represent 4 times 2. So I've hopped 4 units 2 times, and that tells me that 4 times 2 is 8. Alright, no cat sound effects on this one. It says multiply -5 times 4 using the number line model. Alright, so the way that I did dots here, sorry if the sound just messed up. So I'm going to start at 0 and I'm going to hop backward because I have a -5. I'm going to hop back -5 4 times. So 1, 2, 3, 4. Alright, so I hopped backward -5 units, or hopped backward 5 units 4 times. So that tells me that -5 times 4 is -20. Now we're going to look at the pattern model for multiplication. Here we are defining a pattern as something that can be observed repeatedly. Let's try to look at some patterns or observe some patterns in this multiplication table that I'm about to show you. Alright, so here is a multiplication table for 1 times 10. So we've got all of our products from 1 times 10 represented here. So for example, if you wanted to do, let me do my laser pointer. If you wanted to do 6 times 5, you would say, okay, go down to the 5. I'm going to start in my 6 column. I'm going to go down to 5. Alright, so 6 times 5 is 30. Alright, so just a couple of patterns here. You can see in the 5 column, and they're jumping up by 5s. You can see in the last column here, they all end in 0. Same for the bottom row. I'm sure there's lots of patterns you can observe if you just take a minute and look at this. So let's see. Here this goes up by 5, then 7, then 9, then 11. So you can find lots of patterns if you just spend some time looking at this multiplication table. But the type of patterns that your book is referring to are these type of patterns. So just take a second to look at our question here. It says, identify the pattern to evaluate the last 3 equations. All right, so we're given a pattern. We see that this first factor in all of these products is the same. It's -2 for every one. Every one of them is multiplication. And then our second factor here, -3, -2, -1, 0, 1, 2, 3. That's the one that's changing. All right, and here is our products. We have 6, 4, 2, 0. All right, so what pattern do you observe there? I'm observing that it's decreasing by 2 each time. All right, so if that pattern holds, then what I should expect to see happen is that it should go down another 2. All right, so 0 minus 2 would give me negative 2. Then if it went down another 2, negative 2 minus 2 would give me negative 4. Negative 4 minus 2 would give me negative 6. All right, so we know the rules of multiplication tell us that we're going to be able to observe these patterns every single time, no matter what your first number is. So if this was negative 4, negative 4 times negative 3, negative 4 times negative 2, negative 4 times negative 1, negative 4 times 0, we're going to see it changing by whatever that first factor is. So it's going to be decreasing by 4, decreasing by 4, decreasing by 4. All right, so since multiplication is just repeated addition, it is easy to identify these patterns when you have these products lined up like this. Now, we have special rules for multiplication of integers. We have 4 rules. Positive times positive is positive. Positive times negative is negative. Negative times positive is negative. And negative times negative is positive. All right, so your book emphasizes that these rules should only be displayed in this way for students that are struggling, and this is you're supposed to lay out these rules in this matter-of-fact way to help them catch up. But you would your goal is for your students to identify these patterns themselves. Right, so you would like them to identify these rules by observing in the different problems you do, that hey, every time we multiply negative times a positive, it ends up being a negative number. Every time we multiply negative times a negative, it ends up being positive. All right, so we have 2 models we're going to look at for integer division. The first model is the chip model. The chip model for division relies on partitioning your dividend into equal groups based on what your divisor is. All right, so we're going to divide negative 18 by 6 using the chip model. All right, so I'm going to start off with 18 red chips. I'm using red chips because I know that red chips represent negative numbers. All right, and I am supposed to be partitioning these into 6 groups. So I've got my 6 groups here, and I'm just going to start one by one divvying them up. All right, so put 1 in each group. Okay, I still have some left over, so let's do another round. So divvying them up once again. I still have chips left over, so I'm going to do this one more time. Right, now that I have partitioned all of my chips off, I have nothing remaining, then I can say that the answer here, negative 18 divided into 6 groups, give me negative 3 chips in each group. Right, remember, they're still negative because they haven't changed color, they're still red. So we have negative 18 divided by 6 is negative 3. All right, and then this last one, I've got this out of a textbook. It says a machine drill is used to access water under the ground. It's under the ground, okay? So that's important. If the machine drills the same distance each day, what is the change in the location of the bottom of the hole each day? All right, so, and it tells you on that picture that at the very bottom we've got water at 160 feet below ground level. I just noticed you can see the answer down here at the bottom, but just pretend like you can't see that. All right, so we've got our number line here, and I'm going to start at 0, and each day I'm digging down the same amount. It says the machine is drilling down the same distance every day for 4 days. And I know that down there at the bottom, that's negative 160. Oh, Lord. I'll try that again with my pen. Okay. All right, so what your book does here is they change this into a related fact family equation, which is 4 times what gives you 160. All right, so just rewording this or rearranging this into a multiplication problem. That should be a negative. All right, so 4 times what gives you negative 160. We know that 4 times 4 is 16. 4 times negative 4 would give us negative 16. We can get a 0 on the end just by putting a 0 on the end of that factor. So 4 times negative 40 would give us negative 160. So that tells us that the location of the bottom of the hole changed by negative 40 feet each day. All right. So if you have any questions over multiplication or division of integers, please let me know. Otherwise, I will talk to you soon. Have a great day.